Let's talk about stemming. Stemming is literally all about transforming words into their stems. Word stem is also known as a base form of a word. How do humans create new words? We can create new words by attaching affixes to word base in a process known as inflection. The goal of stemming is to reduce inflectional forms to a common base form. The stemming process maps all inflectional forms of a word to the same root form. Consider the word compute. You can add affixes to it and form new words like compute, computed, and computing. In this case, the base word compute is the word stem. The reverse process of obtaining the base form of a word from its inflected form is known as stemming. Stemming helps us in standardizing words into their base or root stem, irrespective of their inflections, which helps many applications like classifying or clustering text, and even in information retrieval. Let's take a short quiz. From the following 5 examples, choose all inflectional forms of open. Pause the video and answer the quiz on Jupyter Notebook. Porter's algorithm is one of the most widely used stemmers. Porter's stemmer, or Porter's algorithm, is a rule-based suffix stripping algorithm. For example, the word duplicatable is stemmed by the following steps. First, duplicatable becomes duplicate by stripping out its affix able, and then becomes its root word duplicate, and then becomes duplic, from which we can create any inflectional forms. The problem of Porter's algorithm is that words often become non-readable after stemming. So in practice, we often skip the stemming process and leave inflectional forms as they are. Lemmatization is very similar to stemming, where we remove word affixes to get to the base form of a word. However, the base form in lemmatization is known as root word, which is different from root stem. The difference being that the root word is always a lexicographically correct word, so it is present in the dictionary, but the root stem may not be so. Thus, root word, also known as lemma, will always be present in the dictionary. For example, am, are, is will be lemmatized into be, and cars, cars, cars into car. How will this sentence be lemmatized? As I said, lemmatization transforms words into their root words. So the root word of chips is keep, that of crashing is crash, and so on. How about was? The word was will be transformed into its root word be. So after tokenization and lemmatization, this sentence will be transformed into this one. In summary, we can think of text as a sequence of tokens, and tokenization is a process of extracting those tokens. Removing special characters and stop words improves model performance. We can normalize tokens using stemming or lemmatization. All right, let's do an exercise. Using the code provided in Jupyter Notebook, remove special characters, including numbers and stop words, and lemmatize the following paragraph. And in the next video, we will take a look at our dataset and summarize the key characteristics of the data. Good luck.